I'm gonna show you a few lava formations, starting with Pele's hair. Pele is the Hawaiian goddess of the volcanoes. This is her hair. In nature, this forms when lava falls over edges and cliffs and stretches out. The beginning of lava eruptions are very good at producing them, because then the lava jumps into the air, and with a lot of wind, billions and billions of these hairs will be produced. The lava is slowly reaching the bottom of the slide. If you look at the upper part of the lava flow, there you can see it's not moving much anymore. The outer layer is quickly solidifying. That layer also protects the lava underneath from the colder air above. So even though on the top it's not moving, there is liquid lava flowing under the top layer inside a lava tunnel. And at the bottom you see, that is still coming out. In nature, that's how lava tunnels form. When the outside layer of a lava flow solidifies first, stands as a structure on its own, and then for some reason the liquid lava inside can escape and leave behind that structure. To show you the interaction between lava and ice, here comes a piece of ice. You can see a lot is happening. The water is rolling off of the hot surface of the lava as fast as it can. Some steam gets trapped under the lava, pushes upwards and expands it into bubbles. And where most of the lava is touching the ice, that lava turns black in color immediately and solidifies very fast. But the whole lava flow is solidifying very fast. You see, it has already become one large piece, and when I lift it, the liquid lava inside will escape. That's all the light and the heat coming from underneath. When the lava cools, it turns into a glass, a volcanic glass, which is called techilite. Techilite doesn't have much silica, 40%, as opposed to normal glass, 70%. And that means that the more our lava cools, the more it's going to break. You can hear the crackling sounds. This is the lava shrinking and breaking itself up as it is cooling. Look how delicate techilite glass is. You can just brush through and it's gone. Doesn't take much. Now in nature, a big lava flow can easily take a full century or two to fully cool down. That's a very long time. Here our tiny little lava flow will not take that long to cool because it's much smaller. But we have tried it one time, leaving the lava flow like this, just to see how long it would take to cool on its own. 3 days later, it was still hot. So we are not able to wait for the lava to cool, because our next show is at 7. So we don't actually have to wait for the lava to cool. After the show, we break the lava up into small pieces that we can scoop out with a shovel. It will go into a bucket, a steel bucket on a trolley that we can roll, so we never directly touch the lava. And those hot pieces will go into the furnace again. The hotter they still are, the easier and the faster it will be to melt again. This is going to be one of tomorrow's lava shows as well. Now, the glow is quickly disappearing. Most lava is turning black in color, but here and there you can definitely see that the lava still has a nice glow. And that means that we have many different temperatures on the lava flow now, and I can tell you a little bit more about those with a heat gun. I will first tell you how hot the coldest lava is. the edge of the lava flow, where it's black in color, 412 Celsius, 770 Fahrenheit. But if I put it at some orange lava, inside of what is left of the bubble, for example, I took off my glove too fast. Yeah. 733 Celsius, 1350 Fahrenheit. So some parts of the lava, you see, they take a bit longer to cool because it's thicker or less exposed to colder air. Maybe also there's a lava formation like a bubble that can trap hot air, or a combination of all of those. But there is one part of our lava that has definitely completely solidified now. It's the Palais hairs that we made in the beginning. They are very delicate and thin. They're very lightweight. In nature, they will get picked up by wind and gathered in corners and holes on top of lava flows. I'll pass them around so you can have a look. In nature, they will last 1 month, maybe 2, and then it just breaks away into a fine dust. So it's not a very strong lava. We have another volcanic glass, however, that is very strong. I will pass a piece of it around as well. It looks like the result of our lava flow, a black volcanic glass, but it's not the same one. This is called techilite. This piece is called obsidian. It's very famous. Dragon glass from Game of Thrones. It has a different composition. Techilite, 40% silica. Obsidian, up to 80. Obsidian is so strong, we can actually make things with it. Tools, jewelry, in the past weapons, arrowheads, knives and blades. And still today, it is used as a surgical blade. If fractured at the right angle and speed, it is the sharpest material in the world. Beautiful and practical. Techilite, beautiful, but not practical. It will break very quickly, as you can see. So in nature, to get obsidian, you need 2 ingredients. The lava has to come from extra deep, then it brings up more silica than lava that comes from a shallow place. And it has to cool fast. That's when lava glassifies. Most lava in nature cools slowly and actually turns into a rock. Glass in nature is pretty rare, but we have some in Iceland. There is places in the world, however, that have way more than we do, and many kinds of obsidian also, all the colors of the rainbow. Here in Iceland we only have black colored obsidian, but we love it though, not complaining. I'm gonna tap the lava flow. It's gonna create fractures, smaller pieces that cool down faster. And I do it now because I want to show you how hot the inside of the lava flow still is. The inside is still very orange. The outside layer is the one that cooled first. You can see how orange and glowing the thick part still is. So you can imagine a lava flow in nature that is a few 100 meters thick. No wonder the heat is trapped there so efficiently and will take many years to slowly escape. But I also break it now because if we only do it after the show, then these pieces will be so hot when we then put them in the steel buckets. The buckets will heat up so much that the wooden trolleys they are on will set on fire. And we had to learn that the hard way. There was nobody to tell us that that was a bad idea. Pretty effective way to learn, because it has never happened since. Okay, and then I would like to ask you if you maybe have any questions. Is there anything else about lava, volcanoes, Iceland, maybe something about the show, something about the video or the next eruption that you would like to know? Did I say it all? Have any of you seen basalt columns? Yeah, on the beach maybe, on the other side? The famous beach. Yeah?
Can we see lava somewhere, like right now in Iceland? Maybe go somewhere around, or I don't know, where can we see it?
Yes, but not orange liquid. Yeah, so we don't have orange liquid lava at the surface now. The most recent lava is from November, and that is close to the Blue Lagoon. Until the next eruption starts, you can drive there and see it from the road. It's still smoking, and it will do that for about 10-15 more years. But no orange lava at the surface now, no. We would have to wait for the next eruption for that, yeah.
So do you guys monitor the volcanoes? Do you know when it's getting ready to erupt and
Yeah.
alert people? And
Yeah. So every volcanic eruption, I should say, gives us a seismic warning, earthquakes, and ground inflation. That's when the magma pushes the ground up. And one volcano will not give us that warning in the same time frame as another. For example, Katla, we expect a few weeks, maybe a few months of earthquakes and ground inflation. The eruptions that are going on now give us about 10-15 minutes warning. That's why when we know that the next eruption will happen, we already evacuate the area. It's already close to the public now. Yeah. Yeah. So we do have a warning, but it's very different from one volcano to another. Yeah. We also still have very big explosive volcanoes in Iceland that give us half an hour warning before the next eruption. So those we don't live close by to. If today we live close to a big volcano, like Katla, it's because we understand it well and we expect a good warning. So Hekla, for example, on the Golden Circle, Askja in the highlands, we stay far away from them because they're still very difficult to predict, and we know the eruptions are very big. Okay, anything else? So what I'm gonna do is open this door to get a little bit of extra light inside. If you have a closer look at the lava on your way out, please make sure that you keep your glasses on because the lava is still cooling and splitting. You can hear it, sometimes you can see it move. So it's possible that more pieces continue to jump out, and that's fine because they cool while they fly, but remember, it's also the sharpest material in the world, so we really don't want that in our eyes. Hence the bowl at the door, please only take off your glasses there. And of course also please don't touch the lava. It will be a hard lesson to learn, so I would rather warn you. And then if you have any questions, come and see me here. I would like to thank you very much for coming to the show today. I wish you all a lot of fun here in Iceland, and I recommend you to enjoy the nice weather. Thank you, that's very nice of you. Thank you. Thank you. That's 2000 Fahrenheit, exactly the same temperature as a lava eruption in nature. And we did this for the first time with an audience here in Vik in 2018. We also have a show in Reykjavik now, and the idea is from 2010 that there were 2 eruptions here in Iceland. One of those caused a lot of trouble, and everybody was suddenly talking about Little Iceland on the news worldwide. It kind of put us on the map. Not for the right reasons, but as we all know, bad publicity is also publicity. So in the years after, we did get extra people coming to Iceland. The volcano in question is half an hour driving that way. Did you come from Reykjavik? Yeah? So you drove by the foothills of this volcano. All the landscape between Seljalandsfoss waterfall and Skogafoss waterfall, half an hour driving of mountains, it is all part of Eyjafjallajökull, this volcano that erupted in 2010. On the top, there is a glacier. So when the eruption happened, lava met ice. It created a big explosion with ash. The wind took this ash to Europe. Flights were cancelled, airports were closed for quite some time. Here in Iceland we got lucky because most of the trouble was blown overseas, far away from us, and our airport even stayed open during the whole eruption. It was funny to see how the media was struggling to pronounce the name of this volcano on TV. but we can't blame anyone. We do have to admit that the names here are a little bit long and difficult to pronounce. But there's a reason why. When you talk about a place, the name of the place often describes the place. So it is more words stuck in one. The long words, you can dissect them, make them easier to pronounce, and if you then translate those small words, it will describe the place you're going to. For example, the volcano from 2010, it's 3 words in one. Eja, island, Fjalla, mountain, Jökull, glacier. Eyjafjallajökull. Piece of cake, it just rolls off the tongue with a bit of practice. Do you want to have a go? Eja, Fjalla, Jökull, Eyjafjallajökull. Oh, fantastic! Well done! You're fluent in Icelandic already. Very nice. So, the eruption in 2010. It was explosive, but here in Iceland, we have one other type of eruption. It's called effusive. That's when the ground slowly opens like a fissure and lava slowly comes out. That has been happening for 3 years now, close to the Blue Lagoon. 10 effusive lava eruptions so far, and we expect number 11 very soon. It will happen in the same place as the 7 eruptions before. It's actually a bit overdue. The sooner it starts, the more logical. Now, in 2010, 1 month before the explosive ash eruption, we also had an effusive eruption on that volcano. But the difference with that eruption and the ones that are going on now is that back then, there was no poisonous gases. So we were actually able to go up and see the eruption from very close. We saw how excited everybody was doing that, and there the idea of the lava show was born. We wanted everybody that comes to Iceland to have the chance to experience that. We will start today with a video on these 2 screens. It will tell you a little bit more about Iceland, and then it will tell you about the volcano that is just behind the mountains here. It's the largest one we have, but its name, it's probably the smallest one we have. And there's a Netflix series of the same name and topic. Do you know it? Yes. Who said? Katla, exactly. So, the video will tell you a little bit more about mighty Katla. After that, the room will go dark. The lava will slowly come into the room and flow in this channel. But here you see the channel flattens out. So when the lava reaches this point, it will spread, and then it will solidify like a lava pancake on the flat part of the slide. This is what we melt to create the lava flow. It is called tephra. Tephra is the result of a volcano erupting under a glacier. When that happens, the lava shrinks, solidifies, and explodes into this. The water then easily takes the sand down to the sea. That's why we have black sand beaches. All of the sand is lava. This particular tephra is from the 1918 Katla eruption. We just melted again to the temperature